Imagine writing code that is, specifically designed to save your computer's memory. You're relying on this highly sophisticated architecture built for just ultimate efficiency.
Right, you're trying to do everything perfectly by the book.
Exactly. So you deploy this one specific function explicitly to optimize that system, only to discover that the exact tool you use to streamline things is, well, it's basically a memory grenade.
Oh, yeah. It just brings the whole architecture crashing down.
Yeah, and that is the frustrating, often completely counterintuitive reality of coding in complex environments. So, welcome to today's deep dive. I'm your host, and today we're exploring a really fascinating entry from a highly prolific blog by a developer named Eng.
Yeah, and the site is kianmeng.org. He actually describes himself as an old software plumber who tinkers in the night. It's a great description.
It really is. And, the reason we chose this source for you listening today is that it's a remarkably transparent look at the actual mechanics of systems design.
Definitely. I mean, Eng isn't just posting these glossy finished successes or like heavily edited deployment logs where everything looks easy.
No, not at all. He is meticulously documenting the exact moments he realizes he's completely sabotaged his own work.
Which is where the real architectural lessons actually live, honestly.
Right. So we are going to dig into one very specific, seemingly minor coding realization Eng had. It's all about memory management in Haskell.
And we're going to use this one tiny error to explore the underlying mechanics of system efficiency.
Yeah, and also the hidden, maybe somewhat hypocritical challenges of open source documentation, plus just the whole mindset of a lifelong tinkerer. So, okay, let's unpack this. Let's start right at the heart of his blog post.
Right at the exact moment, Eng realized his optimization was actively working against him.
Yeah. So Eng was working on this Haskell pet project called X2 ebook, and he's writing a tool that processes text data.
Right. And to manage the system resources for that, he's utilizing what are called lazy ByteStrings. Now, Haskell's lazy evaluation is brilliant for memory, but it requires you to deeply trust the compiler.
Wait, how so? What does lazy evaluation actually do here?
So when you declare a lazy variable in Haskell, the program doesn't compute the value immediately. Instead, it creates a thunk.
A thunk.
Yeah, a thunk. It's essentially a pointer or like a promise to evaluate that expression only when the data is strictly required by the system.
Oh, I see. So instead of loading an entire massive file into your computer's active memory all at once, a lazy stream processes the data chunk by chunk.
Exactly. The thunk gets evaluated, you process that specific piece of data, and then the garbage collector comes in.
Right. It discards the used memory, and then you just grab the next chunk. It's a conveyor belt.
Yep. But what's fascinating here is the massive gap between the theoretical intent of the programmer and the literal execution of the machine.
Because he tried to optimize it, right?
Yeah. Eng applied what he thought was a standard optimization to his stream. He used a function called data.bytestring.lazy.toStrict.
Which sounds like a good thing, like you want your code to be strict and disciplined.
You'd think so. In many Haskell applications, forcing strict evaluation actually is necessary. Because if you let too many thunks build up unevaluated,
You get a traffic jam.
basically, you create a space leak. The pointers themselves consume all your RAM before the actual data is even processed. So Eng thought he was tightening up the code by making it strict.
But applying to strict to an I/O stream completely breaks that whole lazy architecture we just talked about. I mean, it's like trying to drink from a fire hose.
That's a great way to put it.
Because the whole point of chunking is putting a valve on that hose so you get a manageable continuous stream. But using to strict removes the valve entirely. It blasts the entire reservoir at your face all at once.
Yeah, it completely defeats the purpose.
Or, to put it another way, think of it like ordering a multi-course tasting menu at a high-end restaurant.
Okay, I like this.
The whole design of a tasting menu relies on it coming out one plate at a time, right? You eat the appetizer, the waiter clears the plate. You have the soup, they clear the bowl. It's paced out to match the physical space of your table.
Right, you're relying on the restaurant's garbage collector, essentially.
Exactly. But using that toStrict function is like ordering the 10-course meal and then forcing the waiter to bring out all 10 plates. The soup, the salad, the steak, the dessert at the exact same second.
I'm just cramming them all onto your tiny two-person table.
Yes. You have no room to move and the entire dining experience collapses. I mean, what's the point of ordering it by chunk if you force the system to dump it all in the waiting room at the end?
You've completely defeated the architecture. The toStrict function traverses the entire lazy stream, forces every single thunk to evaluate simultaneously, and just loads the entire file into a single contiguous block of active memory.
Which is a nightmare for the system.
Yeah. You think you're protecting your system's resources from a space leak, but a single misunderstood function call instantly creates a massive system bottleneck. It's a trap hiding in plain sight.
So the system is crashing because the table is too full. How does an old software plumber actually fix a kinked hose like this?
Well, Ang's notes detail his shift in strategy. Instead of using that memory hogging too strict function, he completely switches libraries.
Oh, he abandons it entirely.
Yeah, he pulls a function called decode, and yes, that has a little prime symbol at the end of it, from data.text.lazy.encoding.
Right, I saw that little apostrophe thing. What does the prime symbol mean?
That prime symbol is a crucial detail in Haskell nomenclature. It usually denotes a strict version of a function. But here's the brilliant distinction in how it operates compared to su stricto.
Okay, I'm listening.
The decode function evaluates the text strictly within the chunk, but it maintains the laziness across the broader stream.
Oh, so it processes the data aggressively, but only the data currently sitting on the table.
Exactly. Furthermore, decoding UTF-8 as a stream introduces a massive mechanical headache, which is byte boundaries.
Right, because characters aren't all the same size.
Exactly. A single UTF-8 character can be anywhere from 1 to 4 bytes long. If your lazy stream arbitrarily chunks a file right in the middle of a multi-byte character, say like an emoji.
A naive, strict function will just throw an exception and crash.
Right.
Because the bytes don't make a valid character.
Bingo. The decode if8 function is designed to handle that exact state. It intelligently buffers that partial character, grabs the next chunk from the stream, completes the character, and just continues yielding text.
So the conveyor belt runs smoothly without forcing the entire file into memory.
Yep. It's a very elegant fix.
Okay, I follow the mechanics of the fix. It is elegant, but I have to push back on this a little bit.
Oh, okay, let's hear it.
Looking at Ang's own admission in his blog, I had a moment of serious doubt about why we were even discussing this.
Why is that?
Because Ang explicitly mentions that based on his experience working on a related Python project, he rarely handles plain text files that are larger than 300 kilobytes.
Which is, yeah, an incredibly trivial payload for modern hardware.
Right. A 300K text file isn't going to crash a modern smartwatch, let alone a developer's machine. So if the files he expects to process are that tiny, why even bother fixing this?
That's a fair point.
Like, why dig through Haskell libraries to find a prime symbol function that perfectly balances strict chunking with lazy streaming? Isn't this just, I don't know, over-engineering for the sake of theoretical purity? Who cares if a 300K file is loaded all at once or in chunks?
It's a completely fair question. And honestly, it's a debate that happens in engineering stand-ups every single day. Theoretical purity versus practical shipping.
Exactly. Just ship it.
But if we connect this to the bigger picture, Ang's reasoning moves from abstract to hyper-practical. You have to look at the architectural roadmap for XS2 book. He is building support for parallel processing.
Ah, okay. So he wants to handle multiple conversions simultaneously.
Right. Concurrency changes the physics of the system. In systems design, a 300 kilobyte memory hit is absolutely nothing in isolation. But parallel processing means spinning up 10, 50, maybe 100 threads at the exact same time.
Oh, wow. Yeah, that scales up quickly.
If every single one of those concurrent threads hits a toast-strict function and it unnecessarily forces its entire payload into active memory, you aren't just dealing with 300 kilobytes anymore.
You are creating a synchronized exponential spike in memory allocation.
Exactly. It's a multiplier effect. A 300 kilobyte inefficiency isn't a leak. It's a structural weakness that bursts when you add concurrent pressure.
Okay, that reframes it perfectly. You can't scale an underlying inefficiency. Efficiency at the micro level is the only thing that allows the macro level to survive at scale.
Precisely. If you don't fix the tiny leak when the water pressure is low, the pipe violently bursts when you turn the pressure up for parallel processing.
So Ang isn't over-engineering. He is future-proofing the architecture so that the system throughput isn't artificially capped by a single careless function call.
That's exactly it.
But here's where it gets really interesting to me. The very fact that Ang had to go through this whole trial and error process with toast-strict and decoding F8, it points to a much larger structural problem in this specific community.
The documentation or lack thereof.
Yeah. I mean, how do you even know these functions exist or how they handle byte boundaries if you're trying to build something?
Navigating the Haskell ecosystem is notoriously impenetrable for newcomers, and sometimes even for veterans, honestly.
Ang points out that his absolute best lifeline is a tool called Hoogle, spelled Hoogle. It's like a specialized search engine for Haskell.
But you don't search it like Google.
Right, you often search it by entering a function's type signature, meaning you type in the abstract mathematical representation of what types of data go into the function and what types of data come out.
You literally search by the shape of the data.
Which is wild.
It is incredibly powerful if you understand category theory, but it relies on the user already knowing the mathematical shape of the solution they are looking for.
Right. And he has to use Hoogle because, as he bluntly states in the blog, the quality of documentation for many Haskell libraries still leaves a lot to be desired.
That's a very polite way of saying it's often terrible.
So what does this all mean? I have to call out the hypocrisy here, just impartially looking at the ecosystem.
Okay, let's hear it.
We are talking about free, Libra, and open source software, fall losses. And Ang is a massive champion of this. He actively supports the EFF, the Free Software Foundation, Wikipedia.
Yeah, he's very vocal about his support.
The entire ethos of open source is that technology should be accessible, democratized, and free from corporate gatekeeping. Yet, isn't it wildly hypocritical to champion open access but then hide the actual instructions behind a wall of dense mathematics and undocumented libraries?
This raises an important question about the culture of different programming communities and the reality of what we call the documentation tax.
Well, documentation tax.
Yeah, you are absolutely right that there is a tension there. But you have to understand the specific culture of Haskell. It is a language heavily rooted in academia and advanced mathematics.
Right, it's very theoretical.
So in that culture, the type signature is considered the documentation. To a mathematician, seeing, a string to int is a complete and perfect explanation of truth. They view writing out paragraphs of practical examples as redundant.
But to an engineer trying to build an ebook converter, a type signature doesn't tell you if the function forces a lazy stream into strict memory and crashes the server.
Exactly. And that gap highlights the shadow side of the open source philosophy. Writing complex, mathematically pure code is intellectually stimulating. Solving logic puzzles is rewarding.
But writing clear, accessible instruction manuals.
Writing comprehensive manuals that explain edge cases like UTF-8 bind boundaries, that is tedious, thankless work. It's a tax. So in decentralized communities, it often just doesn't get done.
Leaving developers stranded in the dark, basically using trial and error to figure out why their architecture is failing.
Which is precisely why blogs like Ang's are the actual lifeblood of the ecosystem. The open source world survives because old software plumbers take the time to figure out these undocumented edge cases the hard way.
And then they publish part 82 of their notes.
Yes, they are stepping in to pay the documentation tax for the rest of the community. They are writing the missing manuals.
That transition from struggling with undocumented code to becoming the person writing the documentation is a perfect lens to look at the broader scope of qianmeng.org.
Oh, absolutely. The blog's incredible.
Because if you pull back from this one specific post about Haskell memory streams, you realize Ang isn't just mapping one esoteric programming language. The sheer scale of his output is staggering.
It's the digital footprint of a relentless polymath.
He has been blogging consistently since 2011, but the velocity is increasing. In recent years, he has been publishing over 730 times a year.
That is 2 highly detailed, technical, or reflective posts every single day.
2 a day. And he jumps fluidly between disciplines. We just spent all this time on Haskell, but his archives are filled with deep dives into Go, Rust, Python, Elixir, Erlang.
But the digital side is only half the story, really.
Right.
The truly revealing part of his mindset is how he applies that exact same hyper-analytical, optimization-focused framework to the physical world.
Yes, his physical hobbies are just as intensely documented. He takes this systems engineering mindset into wildly different areas. He has hundreds of posts about gardening, for example.
Gardening? Really?
Yeah. He is meticulously documenting his battles with leggy seedlings, tracking the precise growth variables of flame dwarf cultivars, and journaling the pruning cycles of his bougainvillea.
That is amazing. And his fish-keeping logs are even more intense.
Oh, the betta fish.
Yes. He maintains incredibly detailed betta spawn logs. He isn't just throwing fish in a bowl. He is tweaking water parameters, monitoring the nitrogen cycle, and even simulating the monsoon for his fish to trigger specific breeding behaviors.
Simulating the monsoon. I mean, think about the level of environmental control and variable tracking that requires.
It's next level.
For you listening right now, I think this is where Ang's journey really mirrors the curious mind. If you are the kind of person who uses a deep dive to understand the mechanics of the world, you probably cross-pollinate your own hobbies.
Oh, for sure.
You probably take a framework from your professional life and apply it to a weekend project. Ang just does this out loud, and at a massive scale.
Because he views the world, both digital and physical, through the unifying lens of a systems thinker. He calls himself a plumber. And what does a plumber actually do?
They fix leaks.
They study flow, they manage resources, they ensure the underlying architecture operates under pressure without bursting.
Literally chunking the streams, whether it's data or water.
Exactly. Modulating the delicate biological nitrogen cycle in a bed of fish tank, or calculating the exact seasonal moment to croon a flame dwarf cultivar, it really relies on the exact same logic loops as optimizing memory allocation in a Haskell script.
It's all about observing a complex, interconnected system, understanding its limits, making a micro-adjustment, and then meticulously documenting the result.
Treating software in gardening and fish keeping as plumbing fundamentally removes the ego from the process.
That's a great point.
He's not trying to be some rock star developer writing flawless, mathematically pure code on the first try. He's a mechanic going into the basement, finding the memory leak, getting his hands dirty, and applying a patch.
And if the original architects didn't bother to write a manual, he just sits down and writes his own.
It is a radically practical approach to lifelong learning. You don't wait for perfect instructions, you tinker, you fail, you document, and you iterate.
Let's bring this all together. We started today looking at a very specific structural failure in a digital hose. Aang was trying to process text streams efficiently in Haskell, but he deployed a function called toString that completely bypassed his lazy architecture.
Right, it forced the system to swallow the entire file simultaneously, acting like a memory grenade.
He traded stream processing for a massive, instantaneous memory allocation.
A total disaster for scaling.
But by acting like a software plumber, he identified the bottleneck and swapped it for a parallel-friendly solution called decoding. This ensured that when he eventually scales his project up to handle concurrent processes, those tiny memory hits don't multiply and crash his machine.
And through that highly technical lens, we exposed the documentation tax of the open source landscape. A world where type signatures often replace actual instructions, forcing developers to rely on tools like Hoogle just to survive.
Yeah, and we framed all of this within the beautifully obsessive mind of a tinkerer, someone who applies the exact same rigorous variable tracking logic to learning Rust programming as he does to simulating a monsoon for his betta fish.
Aang is out there documenting his failures and fixes across wildly different fields. He's acting as the ultimate scout to shortcut the learning process for you, for me, and for anyone trying to navigate these complex systems.
Charting the territory so the next engineer doesn't fall into the same traps.
No.
Aang's journey shows us that software is just plumbing, and plumbing is just resource management. Which leaves us with a question for you to mull over as you go back to your day. We spent a lot of time analyzing Aang's realization that in parallel processing, tiny inefficiencies aren't just leaks.
No, they are structural weaknesses that multiply and crash the system under pressure.
Exactly. So think about that concept of the lazy byte string being suddenly forced into strict evaluation.
Where in your own life or work are you harboring a lazy byte string? What I mean is, where is there a tiny bottleneck? Maybe a clunky workflow, a disorganized system, or a habit of constant context switching that seems completely harmless when you're just executing one task at a time.
But is quietly acting as a multiplier, draining your mental bandwidth and crashing your internal system the exact moment you try to multitask. Where's your personal architecture failing under concurrent pressure?
Find that kink in the hose and fix the plumbing.
Thank you for joining us on this deep dive today. Keep tinkering, keep challenging the systems around you, and keep exploring. We'll catch you on the next one.